Thank you everybody for joining us for this short video presentation by Michael Foord and some others at Canonical. We're going to be talking about testing your Django application with mock, simplifying your testing process. And with that, I will turn the reins over to Michael Foord. Thank you.
Hello, thank you, Matt. So mock is a Python library that's been around since about 2007. It's definitely not the only mocking library that exists for Python. It is the most popular one. It's not even the only one that's used within Canonical, though, but it is reasonably popular within Canonical. So this is going to be a brief introduction to mock and what it's for, how you use it, and why you use it. And one of the examples we're going to kind of focus on is look at a very simple Django application and show how using mock objects you can make your unit tests more effective and faster tests are always better. So on the screen you should be able to see the PyPI, the Python package index page for mock. Mock is pip installable with pip install mock. It's also available in Ubuntu with apt-get install Python mock. The one in apt-get is version 0.7.2, and as we go we'll look at some of the fancy new features in the very latest version 0.8. So I would recommend, if you can, using the latest version, and the easiest way of doing that is using virtual environments for your development or something similar. Okay, so as a quick introduction to mock, mock is a mocking library, not a framework. It's for creating mock objects or fake objects that you can use to replace parts of your system under test very easily. It's not a framework. It's not opinionated about how you write your tests. It doesn't force you to write your tests in a particular style. So if we use the classic mocking terminology, mock is a spy or a fake or doubles rather than a classic mock object, and it follows the AAA pattern, the arrange, act, assert, rather than the record and replay style that many mocking frameworks use. And as of about a week ago or 2 weeks ago, mock is now in the Python standard library and will be available as unittest.mock in Python 3.3. Okay, so first let's turn to the Python terminal. You can see here I've got mock 0.8 installed into a virtual environment. And some of the most important objects you're likely to import are the magic mock class, patch, the call object, and the any object. As we go, we'll have a look at most of these objects. But the most important of these is the magic mock itself. Very easy to create, instantiate. And giving them a name is optional, but if you look at the repro, you see that the name appears in the repro. That's just useful for debugging purposes. If you get mocks appearing in and you don't know where they came from, they're not expected, it's nice that if you've given them a name, you can recognize them, you can know where they came from. And mocks are very flexible. They by default effectively have an unlimited API. That means we can do whatever we want to them. So we can access attributes nested to whatever crazy level we want, and we can call methods. And what we get returned is a new mock object. And again, you can see in the repro that the repro tells us where the mock object came from. One interesting point is that if we access an attribute, that's another mock object. If we access the same attribute again, it's always the same mock object that we get back. You can see there the IDs are identical. And this is useful so that we can see how we can introspect these objects and see how they've been used. So typically we might pass a mock object into our system under test. The system uses it in some way, and then we want to make assertions about how it was used. This is the arrange, act, assert pattern, where we do some setup for our test the little bit of the system under test that we're going to use. We call the system under test, and then we make assertions that the right things have happened. And if we're using mock objects, we can make assertions on the mock object that they've been used in the right way. And mock objects, the mock objects here provide various ways of making assertions. So let's create a new mock object and have a look at some of the ways that mocks allow you to introspect them and see how they've been used. So one of the things we can do is we can set a return value. And then if we call our mock with whatever arguments are appropriate, you can see that the return value we set is returned to us. And then we can assert that this mock was called once with the arguments that it should have been called with. Now if we suppose we expected it to be called with a different set of arguments, this assertion will fail, and you can see in the failure message that it tells us what we expected. The expected call was 1, 3, and then spam equals 99, but we actually got called with 1, 2. There's various other attributes as well that we can look at. There's a Boolean, mock called, call count, and one of the most important attributes, this is something that's new in 0.8, mock calls, which records all the calls to the mock and to its children. As well as the assert called once with method, assert called once with checks that the mock was called with the arguments we specify, and also that it was only called once. We also have the straight assert called with, and that only checks the last call and doesn't check the call count for us.
Can you show us how tracking the calls to children mocks works?
Sure. Okay, so we have our mock. We can see it's been called once with that set of arguments. Suppose we call the foo method. Now mock calls has been updated to include a call to foo. Now suppose we call mock foo again. That's going to return to us that mock shown above, and then we call that, and then we call the bar method on that, and the result of that we access the foo.bam attribute and call that. So you can see there's a whole bunch of calls in one line. It's a silly chained calls. Sometimes it makes sense in your code to make chain calls, but if you ever actually write code like this, hopefully somebody will catch it in code review and ask, why in God's name are you doing this? But let's suppose you have some really good reason for writing code like this. You make the call. Now mock calls is going to have recorded all of those calls. And you can see it's got a whole bunch of entries, because that one line is actually 1, 2, 3, it's 4 calls in one go. Now, suppose our code had done this and we want to assert about this. One of the things that mock provides is the call object. And you can see that repr there uses the call notation. We can actually use the call object to reconstruct that. So if we just wanted to assert about the first entry in that list, we can check, is that equal to call 1, 2, spam equals 99? And that's true. Let me just create a new, let's create a new mock. And I'll show you a neat trick for making an assertion about multiple calls all in one go. Okay, so we've got a fresh mock, and we're going to make this ridiculous call. Okay, and there we've got the mock calls. That records the 4 calls from that silly bit of code there. Now we can obviously reproduce the call for the last call by with this, but if we had to manually reproduce all of the calls there, that would kind of be a bit annoying. It would be like 4 lines of code to make one assertion. So the call object has this neat method called call list, which takes a nested call and collapses that into a list of calls. So what we can do is, let's store that as our calls, and we can just check. So what's been recorded in mock calls should be equal to that set of calls. So using the call object and the mock calls list, we can make assertions about the way, if we have a top level mock and it's representing part of our system under test, it's representing an API, and various calls are made to it and its children. We may have set it up and configured it first. We haven't looked at all the different ways you can configure mocks, but you can then very easily verify a whole set of calls just with one assertion at the top level. So we've looked at how we can set the return value of mocks to configure them, so I can obviously do mock, as well as doing that in the constructor, I can set that on attributes. So now every time we call. But setting return values isn't the only thing that it's common to want to do with mocks. Another very common thing is to say we wanted to test some corner case of our code, and we pass an object in, and sometimes calling a method on this object might raise an exception, and so we want to test the exception handling in our code. Mocks have a side effect attribute. Again, that can be passed as a keyword argument in the constructor. Side effect is very flexible. It can be used for all sorts of things, but one of the things you can do with it is set it to an exception class or instance, and now when we call mock.bar, that exception is going to be raised for us. So if we pass this object into our system under test, it calls the bar method, this exception is going to be raised, and we can test either that the exception is propagated or that the exception is logged, or whatever we expect to happen with that.